Imagine trying to find out the favorite sport of 1,000 students, and you only have 5 seconds to do it. If you're asking people one by one, it's impossible. When we collect facts, numbers, or observations about the world around us, like those students' favorite sports or even their height and weight, we simply call that entire collection data. But in its rawest form, data is usually just a messy list. Look at this table. When the information is unstructured like this, you can't tell which sport is the most popular without scanning every single row. Without an organized structure, raw data is just noise. To actually understand what the information is telling us, we need tools to sort and group it. Take a smaller scenario. A teacher needs to bring sweets for the class to celebrate the new year, but first, they need an accurate count of how many students prefer jalebi, barfi, or gujiya. This is where tally marks come in. As each student shares their preference, the teacher draws a single vertical line next to that sweet. To speed things up, every fifth line is drawn diagonally across the first 4. Grouping lines into these bundles of 5 replaces manual one-by-one counting with quick multiplication, making it easy to see that 13 students chose gujiya. Tally marks work well for a single classroom, but if you need to track the attendance of an entire school, drawing hundreds of individual lines becomes inefficient. A pictograph solves this by using a single visual symbol to represent multiple units. In this chart, one smiley face stands for 10 students. The system even handles smaller numbers by using partial symbols. Since a whole face is 10 students, this half smiley represents 5. Using icons allows us to compress a larger dataset into a smaller space, making the totals readable without counting every single person. But icons have their limits. Imagine tracking the thousands of vehicles that pass through a busy Delhi road crossing every hour. If 1,200 cars pass by, even if one icon represents 100 vehicles, the chart still becomes cluttered and slow to read. When we scale up to the population of an entire country, where we are counting hundreds of millions of people, drawing pictures is no longer practical. At this scale, we move to the most efficient tool for massive datasets, the bar graph. By replacing literal pictures with abstract bars, we can organize vast amounts of information into a single compact view. A bar graph is built on 2 intersecting lines called axes. The horizontal axis usually lists the categories, while the vertical axis tracks the numbers. This graph tracks India's population growth. On the left, the vertical axis scale represents 10 crore people per step. We can instantly compare 50 years of growth. We see 2001's population was nearly 3 times that of 1951, just by comparing bar heights. A consistent scale ensures that even when numbers are massive, the data remains organized and precise. These graphs help us understand performance in almost every field. In cricket, they show us exactly how many runs a player scores match after match. This chart condenses Smriti Mandhana's performance across 8 matches into a single view, showing her highest scores and her low points side by side. We use the same methods to track the recovery of endangered tiger populations or to manage a household budget. Turning raw lists into visual charts allows us to identify patterns and totals that would otherwise be lost in a sea of numbers. Now we want to collect some data from you. Comment your favorite sport below, and we'll use the results to build a custom bar graph for the channel.